The purpose of this recording is to demonstrate that Oracle Extended Distance Clusters can be successfully implemented on Dell Compellent Storage Centers and survive a catastrophic outage at one data center hosting one of the storage centers. The architecture, installation, configuration, and performance tuning of extended distance clusters are out of scope with this recording. Extended distance clusters are also known as stretch clusters and are synonymous with two specific types of geoclusters: campus clusters and metro clusters. The differentiator between the two is spanning distance between nodes. Oracle clusters are implemented using Oracle Clusterware, a high availability infrastructure software solution that is integrated with Oracle's Real Application Cluster, also known as RAC, and allows one to cluster an Oracle database. Oracle RAC allows a database to run an application across the cluster, providing higher levels of application availability. If any server in the cluster fails, the application will still function normally. RAC also provides scalability within the environment. If additional servers are needed to help distribute the workload in the RAC cluster, other servers can be added without generating an outage to the users. Prior to 11G R1, there were latency issues with I/O in a RAC environment because Oracle always read the primary copy of the mirror extent regardless of which node initiated the read. Extended distant clusters didn't fare as well as local clusters, as there was always this needless network traffic. 11G R1 introduced the ability to allow a node in an extended distant cluster to access local failure groups rather than remote groups. This allowed Oracle to read the mirror extent rather than the primary image. However, to realize this, one needs to use preferred ASM read groups. This diagram represents a two-node extended distant RAC cluster. Each node has its own local disk. Node 1 at site A has local disk residing in Storage Center 11. And node 2 at site B has local disk in Storage Center 14. The fabric is modified in such a way that both nodes can not only see its local disk, but the disks of the remote nodes. So, node 1 can not only see its local disk in Storage Center 11, but it can also see the remote disk in Storage Center 14, which is assigned to node 2 at site B. And node 2 can not only see its local disk in Storage Center 14, but it too can see the remote disk on Storage Center 11, which is assigned to node 1 at site A. There's a third storage center involved in this architecture, Storage Center 6. It is used to hold a third voting disk. Now I'll demonstrate an extended distant cluster surviving a catastrophic outage with a storage center. The outage will be simulated by removing the zones to Storage Center 11 used in the cluster from the fabric. After the failure, recovery will be performed by re-adding the zones to Storage Center 11 and making the ASM disks usable. I'll pause the recording momentarily to open the necessary windows for the demonstration. There are 4 PuTTY sessions open to the extended distant cluster. The 2 top windows will be used to display record counts from the same table in the RAC database. The top left window will be a session to node 1 Bach at site A. The top right window will be a session to node 2 Mozart at site B. The bottom left window will be a session to node 1 Bach and will be used to insert records into the table that will be used in the 2 top windows. The bottom right window will be used to display the status of the ASM disks prior to, during, and after the outage. Prior to the outage, you'll see the status of the ASM disks as online and available. After the outage, the status of the disks will be offline. Now let's begin the demonstration. Let's connect to the instance on node 1 and query the records in the target table. You can see the table has no records. We should see the same record count when performing the same select on node 2, Mozart. You can see the same record count from node 2. Now let's use the bottom right window to connect to the ASM instance on node 1, Bach, and display the status of the ASM disks used by the rack database. Now I'll run a script which will display the status of the ASM disk. You'll notice that all the disks are online and normal. They are also named in such a way as to indicate which storage center is hosting the disk. Disks that end in SC11 are hosted by Storage Center 11 and are local to node 1, Bach. Disks ending in SC14 are hosted by Storage Center 14 and are local disk to node 2, Mozart. Now let's begin the insert job. In the bottom left window, I'll begin an insert process to insert rows into the target table. Now I'll verify the records are being added. Now that we see rows being added, I'll pause the recording while I remove the zones to Storage Center 11 from the fabric, which will cause the outage. Now that the zones are removed, I'll redisplay the status of the ASM disk to show the ASM disk offline to Storage Center 11. Notice the ASM disk is offline to Storage Center 11, and yet the insert job is still adding rows to the table. I'll verify the inserts are still proceeding by issuing the select count in the top two windows. Now I'll pause the recording again to re-add the zones to Storage Center 11. I re-added the zones to the fabric, and while that was being performed, the insert job completed, adding the requested rows to the table. I'll verify the record count by reissuing the select count in both top windows. Even though the zones were re-added, the ASM disk status is still offline. To show this, I'll reissue the query against the status of the ASM disk. What one must do to make the ASM disk usable is to remount the ASM disk associated with Storage Center 11. I'll issue 3 alter statements, one for each of the disk groups. Now I'll redisplay the status of the ASM disk. You'll notice all ASM disks are back online. This concludes the demonstration of extended distant clusters using Storage Center.